Hello, I'm Sheikh Jalal Ahmed from Fat Cat Motorsports, and you are watching a video where I'm going to give you some key questions on what you need to have answered from a suspension vendor to make sure that you avoid running into trouble, having an outcome that you're not going to be happy with. And this is not a specific to one person. This is a general idea of something that has quality, something that's been made well, intelligently, to consider you, to respect you, is going to have a universal feel behavior that is going to satisfy anybody's goals, whether it's better comfort or better performance or performance that doesn't beat you up in the process of going as fast as you can, like rally style, supporting the car, supporting you, respecting you, versus NASCAR circle track, which only works on NASCAR circle track. But a lot of vendors do that. A lot of factory cars are doing that. So here are the 6 essential elements, and then there's 3 additional bonus questions. You probably can't see all of them because of the way the screens are set up right now. But the 6 essential ones questions you need to ask, a Q&A to qualify your suspension vendor, are: does your suspension have flat ride? Number 1. Absolutely most important question. It will tell you a whole lot about how much they know, what they're willing to tell you about essentially what the spring, not just what the spring rates are, because most vendors will tell you spring rates, many will. But your question is specifically, am I getting a frequency higher in the rear than the front to give you the settling response, the faster settling and more playful behavior of the car if you want that. But either way, it's going to make the car work more harmoniously, smoothly, better. So this is a key question. If they don't answer this, they can't answer. If they cannot answer, if they don't know what flat ride is, then you say, please can I talk to an engineer, or talk to a designer? But this is a question I need to have answered. Does it have it, yes or no? Second question, does my vehicle package, cargo, power output, tire type, wheels, any mods you've done to add or reduce weight, does that matter when you are going to tell me the package that you recommend? Sometimes vendors will have, their own different stages, or stage 1, 2, 3, or their comfort or performance. So a lot of them will give some level of adjustment to different stiffness or softness goals that you might have. This is a bit of a leading question, because asking, how much does how my car may be unique, how my car, truck, van, whatever may be unique, do you factor that into your recommendations at all? And that is something that I do at Fat Cat Motorsports. It's also why I put up here the corner weights. Like I said, corner weights matter. I mean, asking somebody what their vehicle weighs and taking it to the step of saying, well, if your two front corners weigh different than each other, then you may want to have a stiffer spring on whichever side has that higher weight, so that when the two fronts are oscillating, you don't get an out of phase relationship. You get them bouncing in phase. And same thing for the rear. You get the side to side frequency matching, not just front rear, which is important, front and rear, but the two fronts that are oscillating together and the two rears that are oscillating together. And I found this to really matter, especially, for example, if you have a car, if the driver weighs much more than typical, or much less sometimes. Usually more is when you really notice this, or if you've taken weight out of the car. Especially for racers. I mean, anyone who's trying to buy a high performance setup, and if the vendor say, yeah, we got a package on the shelf, or it's a race package, and yeah, here's the spring rates. You're like, okay, well, spring rates are nice, but what are the frequencies I'm going to get? Okay, that, again, number 1 question. Number 2, well, do you want to know anything about my car, my setup, what I weigh? Well, does that factor in or not? And again, number 2, that's a very important, relevant question, because not everybody came from the same cookie cutter or has the same needs and desires. So including things like power output, or if you have aero or different amounts of grip, maybe they ought to ask a few more questions than they may right now, just like other than make, model, what do you maybe want to do. It's like, well, my car, I want to go racing and I've taken a whole lot of weight out of it, you know, does that matter to the way you tune the springs, pick the springs, or the damping? Number 3, so what are, based on whatever spring race you recommend, you know, what are the actual ride frequencies? So the first question is more about, does it have flat ride as a general yes or no? Because if it doesn't have flat ride, it has what's called pitch, which is the opposite of flat ride. And by this point, if you hopefully have watched some of the other videos that I've created, where pitching is this teeter-totter seesaw behavior when the front is a lot stiffer than the rear. So as the car is going down the road, the front's really kind of driving the rear down, so you get the seesaw effect as the car goes down the road, and it's very bucking. Like if you put your head against the headrest, you'll feel it getting whacked as you're going down the road. It's bad for comfort, bad for grip. It feels very busy and sporty, but sport is a 4-letter word. It really is, the more you get into understanding what's going on. So like, what are the frequencies? Because you may want something that's more on the touring side, something that's softer, maybe in the range of something 1.6 hertz front, which is a more soft setup, 1.8 rear. I had this in some of the other videos that I put out on, you know, the overview of Ride Harmony concepts, you know, the essential foundational videos that I've created. Or you may want something that's in the racing area that's more on the stiffer side. Maybe you want 2.2 hertz front. You're going to go racing, you're going to have R compound tires, or you're running 200 tread wear on the track or autocross. So, you know, the frequency does matter, and a good designer of any suspension is going to know what the frequencies are. And also, if you input a certain amount of car weight, then that's going to change the frequency. So that's why each of these questions, they kind of build upon each other, they tie together. Now, the fourth question, for the damping behavior, do you use more what I call NASCAR circle track, which is pulling down, more rebound bias, the more damping on the rebound side, pulling the car down? Or do you use more rally style damping, which is more compression bias, or say more neutral compression than rebound, it's more balanced, to support the chassis better, which gives you better grip, better comfort, better lap times? It's universally a superior design, unless you're running NASCAR circle track, in which case you're probably not calling a regular aftermarket vendor. You're dealing with somebody who deals with circle track specifically. So for road going cars, for track cars, autocross cars, these are reasonable questions, important questions to ask. And again, you can ask them if they will share dynographs with you. I no longer share dynos of what I do. I go into great detail of the type of approach I'm using, so if you can rub a couple of brain cells together, you can likely figure out a lot of what I am doing, although the specific secrets I keep a bit to myself if I can. However, I want people to understand the essential concepts to create this harmonized, synergized, you know, ride, harmony, and race synergy. If you want to go racing, Ride Harmony's foundation, then you build the race synergy on top of that. So you can ask if they have dynographs. Sometimes they'll provide them, and that can be very useful. But another part of the dynograph that doesn't actually always show up is, because most of the shock dynos, if you've seen any of them, often you will have, I'll take a little bit of space that I can, you'll have a curve that goes right through 0. And it looks, oh, okay, this is cool. So this is, you know, the force is on the vertical axis, and the velocity, the speed that the damper is moving at, not the road speed, but the speed that the shock itself is, you know, is cycling the shaft at. At zero velocity, it shows, oh, there's zero force, or about zero force. Well, in actuality, because of the gas force, means anytime, especially on a monotube, if you have a monotube damper, the charge pressure inside the damper creates a static lift, which doesn't just add to the ride height, because a lot of people think, oh, if I put in a Bilstein, it'll make my car higher. Or if I put in some other monotube type shock, Öhlins or MCS or something, it'll make the car sit higher because of the gas force. Yes, it does, except you have put a spring inside the damper, and the damper is meant to be a velocity sensitive device, but the spring is a position sensitive device. So you have changed the damper's behavior to now effectively have a capacitance, a resistance that must be overcome every time you're trying to go into compression. And in another video, I demonstrated a difference between this H&R inverted monotube that has lower gas force and lower rod force / gas force, same thing, versus this MCS, which is non-inverted with a much larger. This is the actual working shaft on the MCS, 22 millimeters, where the H&R, the working shaft is down here, it's 11 millimeters. So literally from 11 to 22, you have 4 times as much gas force, because it's the calculations for area, because you have to depend on the rod, the area of the rod, it's pi r squared. The radius is squared. So the radius is 5.5 millimeters here, and it's 11 millimeters here. Half. This is double the gas force. This is an essential question, especially for people who are looking to put a set of suspension components, dampers, struts. You know, damper is a general term. Strut refers to if it's a front strut, where if you take the strut off the car, the wheel will basically flop around. If it's a shock is going to be mounted more inboard from the wheel, so you can take the shock in and out, but the hub is going to be independent. The wheel is independent of the shock. So, and actually you can see this is for a Miata, this is a 14 millimeter shaft. This isn't bearing a lot of load, really. It's not bearing the wheel loads at all. So you can use a much smaller shaft on a Miata. So it's so important to understand that the gas force or rod force has a effect. It has a constant effect that you can't just pretend it's not there. So the actual curve could actually be offset upward. You get this offset from the gas force that is creating this immediate jerk. And jerk is a sudden change in acceleration. It's not a smooth change, because literally the force is, there's no movement, boom. Then as soon as you overcome that amount of gas force, now there's movement in the damper. This is why anybody who's experienced a high pressure monotube and can feel this ratchety, rattly behavior, it's such a endemic and almost impossible negative to overcome unless you've changed the design or you've added some other capability like a head valve or certain tricks to be able to make the gas force less of an issue. But it's such an important question. Really is, in fact, even if you get flat ride working for you, okay, the vendor does flat ride, great, and whether or not they ask you for your corner weights, okay, it's a bit step further than many probably go. And but the ride frequencies could be in a region that you find comfortable. They work for you, and even the damping, maybe they do give you some amount of balanced damping. It's not too rebound biased, or they say, oh, you can make the adjusters get to a more balanced place. But if this is too high, if your gas force is over 40, 50 pounds in the front on a strut, when it's mounted right at the wheel, the damper's right at the wheel, your strut's right at the wheel there. Or if it's on a double wishbone, if you're in the 40 to 50 pound or higher, then it's deleveraged usually, but you still can feel it. Then this is just going to create this background chatter because the damper just will not track the ground. It's just, the tires are basically being shocked, and the whole car is literally bouncing off of the gas force inside the damper, and often the sidewall of the tire becomes your active spring. So this is a super important question. As I'm making this video and talking about this, I have my notes over here, and flat ride is essential. If you don't have flat ride, then everything else is basically just window dressing. It's not going to matter. It's going to just still be garbage. Pitch is, they wrote down here, pitch is S-H-I-T, okay? That's what it is. Pitch is shit. Then after this gas force question, which again is very important, and whatever else they tell you, they need to be able to answer this. If you ask them about flat ride and you ask them about gas force, almost anything else, okay, yeah, the damping, you can always have dampers tested if you want to. There's places you can send things to if you want, right? Then do your dampers, this is the sixth question. So I'll end this video after this, and I'll go into the 2 bonus ones after, or the 3 bonus questions afterward, into part 2. 6, do your dampers have any provision to filter high frequency road roughness? And that's what I call ripple reducer, which is where the damper has holes drilled into the piston so that there's an ability on very small displacements. I'll try to grow do I have a bump stop segment that I can use as a mini damper, but let's pretend this is a piston. So there's through holes drilled in the piston. So as the shaft goes up and down connected, then there's a little bit of fluid flow at very small motions, like literally just going down a straight road. You're just tooling down the freeway, you're going someplace, not turning, there's no bumps, it's just regular road roughness. Then the damper with the holes drilled is going to be able to cycle with less force buildup, so that force doesn't have to be conducted into the suspension and to the tires and to you. So it's literally just allowing a little bit of a oscillation until there's a big enough movement, and then the force will build up and it'll start to provide resistance. Because there's no benefit to having road features be communicated to you. In fact, there's a detriment, because you get less grip, you get less comfort. The tires are now starting to bounce across the ground. So having any type of capability, I mean, Öhlins has a DFV called dual flow valve. I think that does some frequency filtering. I think it's more, it's like one size fits all from what I can tell. I think they just put it in and that's what they give, but at least they think about it. So I'll give credit to them for that. Any damper that you can turn full stiff. So I'll continue in the next video. But so that's the question about frequency filtering. Like, do they have anything that they do, or you can ask, do you drill holes in your piston? Do you have any provision for that? And if they do, great, because that means that they've thought that this is something that can increase grip and comfort. So I'll finish in the second part. So thanks for watching this one.